Hello and welcome back to video 3 for topic 3, networks, and today we're going to be describing how communication over networks is broken down into different layers. Remember, this is for the IB Diploma Programme in Computer Science. We're still on the third out of 4 core units, and we're on to video 3 out of 5 for this first part, network fundamentals. So, what do we need to know? Well, we're going to be exploring the OIS and TCP/IP models in networking. But what does all that mean? Well, you need to be able to understand the concept of layering in network communication. We're going to be introducing OSI, as I just said, and TCP/IP models as frameworks for network communication. We're going to be highlighting the advantages of using layers in networking. So by the end of this video, we should be able to describe how communication over networks is organized into different layers, list the layers of the OSI and the TCP/IP models, and explain how the OSI model facilitates abstraction and the function of the TCP/IP model. The concept of layering, as you can see here, we've got some layers going on here. Network communication is complex and involves multiple processes. To manage this complexity, communication is broken down into layers, each with a specific role. So if we use a real-world analogy, think of a network layer like a production line, where each station, each layer, has a distinct task to perform in the process of creating a final product, i.e. data transmission. So we've got the OSI model here, and here are the layers 1 to 7. So let's have a little look at the OSI reference model. The Open Systems Interconnection OSI model is a reference framework established by the National Standards Organization, ISO, to standardize communication across diverse systems. Now, the purpose of the OIS model, it provides an abstract depiction of the network communication process, ensuring that different systems can communicate effectively. We've got these 7 layers, but we can split this up into the physical communication, mostly hardware, and the virtual communication, mostly software. Okay, so the top 3, physical, data link, and network, and then we've got transport, session, presentation, and application layers. Okay, I've put some examples on here, but if we go to the next slide, you can see I've sort of gone into a little bit more detail. So the layer 1 is the physical layer, and basically this is the physical structures such as cables and the hubs. Data link, this is to do with error handling, correction, or physical transmission, node-to-node data transfer in a data link. The network itself, handling routing of course, packet forward across the network. An example protocol might be IP. Okay, the transport layer, end-to-end data transmission via TCP or UDP. The session, it manages sessions between 2 users. Application session setup, coordination, and termination. Now, the presentation layer provides data format information, data compression and encryption information to the application. An example of this protocol might simply be a PNG file, portable network graphic. Okay, and then finally the application layer, this performs various services for application used by the end user. An example protocol here might be Hypertext Transfer Protocol or HTTP. So they're the layers of the Open Systems Interconnection model or the OSI model. Okay. Now, there is another model which we mentioned earlier, the TCP/IP protocol model. The TCP/IP, basically Transfer Control Protocol, the Internet Protocol model, and this describes the functions of protocols required for communication over a network. Function of TCP/IP, it's structured, as you can see here, into 4 abstraction layers. TCP/IP ensures successful communication between users by defining how data should be packaged, transmitted, and received over the network. So, as you can see, the physical and data link has become the link layer, the network access layer. The network is still the internet layer. The transport is the transport layer. And then session, presentation, and application layers from the OSI model have become the applications layer. So how does this all work? How do layers facilitate communication? Well, what are the layer functions? Each layer in both the OSI and the TCP/IP models perform a specific role, such as data formatting, routing, or encryption, and passes data to the next layer. Okay? Packet transmission, data is broken down into packets. Yeah. Each containing data and control information. Basically, who the sender was, who's going to be the recipient, what's the number of the packet, because the data is broken down into lots and lots of packets. We need to know which number it is so we can reorder it when it gets to the receiver. So that would be the sort of the control information. which then travels through the network layers from node to reach its destination. Okay, or in terms of packets, to reach their destination. An example, software applications send a data request which passes through various layers for processing and transmission before being reassembled at the destination. So, advantages of layering, 4 things. Manageability. Breaking communication into layers makes complex networks easier to manage and troubleshoot. Modularity. Each layer can be developed and improved independently, allowing for advancements in technology without affecting the entire network. Interoperability. Standards within each layer ensures that the products from different manufacturers can work together seamlessly, so we can link hardware from different companies. And a common language. Layers provide a common language for networking, making it easier for developers to create applications that can communicate across diverse systems. So there is the advantages of layering. Abstraction and flexibility. The OSI model as an abstraction. The OSI model serves as a theoretical framework, helping to conceptualize how different network functions are divided into layers. And if we're talking about TCP/IP model flexibility, while OSI is more abstract, TCP/IP is practical and widely implemented, offering flexibility in real-world network scenarios. I'm sure most of you have heard of TCP/IP, certainly IP addresses, but you may not have heard of OSI, certainly before this video. So just to conclude, just to sum up, network communication is broken down into layers. You really need to know how these are and why they've been broken down into layers, basically to manage complexity, with the OSI and the TCP/IP models serving as key frameworks. Understanding these layers helps in grasping how diverse systems communicate effectively in today's interconnected world. Okay, and as always, I've given you 3 questions. I'll read these through, pause the video, have a little go, and then press play and watch and see how your answers compare with my answers. Okay, so first of all, number 1, list the 7 layers of the OSI reference model. You might need to rewind the video. Describe the role of layering in network communication and how it simplifies the process of sending data over a network. And finally, question 3, explain how the OSI model facilitates abstraction in network communication and discuss the benefits of this abstraction for software developers and network engineers. Okay, and this is for 6 marks. So ideally, 6 bullet points on this one, or 3 bullet points and then a detailed explanation. This one, well, yes, again, if you can give me 4 bullet points, brilliant. And yeah, if you just list the 7 layers, I'll give you 6 marks. So here we go. There are the 7 layers: physical, data link, network, transport, session, presentation, application layers. Question 2, layering in network communication divides the complex process of data transmission into manageable sections, with each layer responsible for a specific function such as routing, data formatting, or error checking. This modular approach simplifies the process by allowing each layer to focus on a specific task, making it easy to develop, troubleshoot, and manage network systems. Data is passed from one layer to the next, okay, once that layer is done with it, ensuring that each part of the communication process is handled effectively. And then finally, with more detail here, the OSI model facilitates abstraction by providing a conceptual framework that divides network communication into 7 distinct layers, each responsible for a specific aspect of the process. The abstraction allows developers and network engineers to focus on individual layers without needing to understand the entire communication process, the entire goings-on of the network. For example, a developer working on an application only needs to interact with the application layer, while the underlying layers handle the data transmission. The benefit of this abstraction includes easier troubleshooting, modular development, and the ability to update or improve individual layers without disrupting the entire system. Additionally, abstraction provides a common language and standard that different technologies and manufacturers can adhere to, ensuring interoperability and compatibility across diverse systems. Okay, that is it. That is it for video 3. Thank you very much indeed for watching. I hope you've gained something from that, and I will see you next time in video 4. Until then, bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.